Hello, hi everyone. My name is Gil, and I'm so happy that you're with me on my talk here, DevOps 101 for Non-devops. So, a quick introduction is in order. My favorite tagline is a Gil of all trades. I'm the founder and one of the admins of the Israeli Women in DevOps. I'm a tech blogger. You have my blog's URL there. I'm a volunteer for several groups, Bahat, LGBT, TLV Pride Center, OpSchool, Apple Seeds, Transpose, and some more. And I'm a DevOps evangelist for a small startup called CubeXAI developing cutting-edge DevOps solutions. So, what are we in for today? First, we're going to start with a bit of theory, history, the DevOps manifesto, things that were before the DevOps revolution. Then we're going to discuss some of the concepts that have been developed on the basis of this theory and trying to extract the benefits of the theories suggested. And then we're going to look at some tools that realize or actualize the concepts into working tools. And then we're going to wrap it up with a summary. Okay, so let's start with theory, definitions, and history. So DevOps started its life, so to speak, as a manifesto about Dev and Ops working together, and an end to what was affectionately, well, not really affectionately, called toss across the wall development. So back before this manifesto, or rather what this manifesto was trying to tackle, is silos. That is, we had a developer team, they would complete their development up to a certain point, and then they would just throw it away to the QA team. The QA team would process it, go over the instructions, maybe return some bugs back to R&D, but once it felt like it was done, then it would be tossed again across the wall to either customers or solutions engineers trying to install things for customers. And unsurprisingly, it didn't work well. This disconnect, this lack of communication, of rapid and efficient communication between the teams was hampering software development. It was slow, it was painful, it was frustrating, and I was there. So even if you weren't, you can trust me, or you can look on the internet and see all sorts of interesting pieces of history. But you know what? That's over a decade ago. Things have changed so much since. So the things that the DevOps Manifesto stressed is individuals and interactions over processes and tools. Now that sounds kind of funny when you consider the plethora of tools and processes that we have in the DevOps world, as even the first slide showed, but those tools are now driven by individuals and interactions. They are much more tailored to the success of the function, individual, and sharing and interacting. So yeah, that's a big difference still. Working systems over comprehensive documentation. Again, same thing. The systems that accompany this software creation and the debugging tools and trying to make it better are better than just, let's say, doing your job, writing what you did, writing the limitations and so forth. That just didn't work. And bringing us, again, so did contract negotiation not work. Collaboration proved itself to be much more powerful than just sticking to a contract that says, okay, for example, my code is relatively complete, now it's your turn. And last but not least, responding to change over following a plan. Again, if you were just following the plan and saying, yeah, I did my thing, now it's your turn, it didn't work. It was inefficient. The plan worked, the product didn't. Okay, so, but like I said, that's long gone, that's history now. Now we have some new ideas and principle. One of them is developer experience. That is making sure the developers are being efficient, that, they're working on whatever they're working, and it's crucial that they do their thing correctly and efficiently, because if they don't, it drags the whole chain along. And as we would soon see, things return to the developers and they have more responsibilities. So developer efficiency is now becoming so crucial that it deserves a concept of its own. And then we have CI/CD. Even after the developers supposedly finished their work, they need guardrails. They need psychological safety, that they know their work is tested and done and secure, and everything is in top shape before it reaches production. Because once it reaches production, it may be a bit more costly to fix mistakes. And if we can stop things from affecting customers, and at the same time help the developers know or be sure that their work is of good, decent quality, then yeah, we gain a lot in velocity. Velocity is a word we're going to hear more and more when it comes to DevOps. And then we have cloud. Back in the days, you would have to provision the resources in advance. You'd have to buy servers, put them in a rack. That was inefficient and that was inflexible, and it did not respond well to change. Cloud changed that, because now we can certify that production is properly provisioned and grow it and shrink it as needed. And last but not least, very important, is monitoring and root cause analysis. Because even with all these improvements, things will go wrong. And when they go wrong, you want to know about it as quickly as possible, because that also produces psychological safety, in the sense that you can fix it or revert it. And obviously, when things go wrong, you want to improve your processes, hence root cause analysis. You need to find out what happened, but you need to also make sure that it doesn't happen again, whether by improving your developer experience, the CI/CD, or your cloud footprint. Okay, so let's dive deep into it. DevOps, developer experience, is roughly the name for local software and processes that optimize your ability to develop. They help you comply with standards, things like linting, formatting, security, and more. And they give you fast to immediate feedback. If I'm trying to commit a code that doesn't pass linting or formatting or security, I will get a stern warning. And that's good. And that helps me know that once I've committed something, I have reasonable safety in knowing that it's secure. And another important thing is minimizing gaps, or as I like to call it, knowing what's down the road. Because you have your developer environment, but production is ultimately different. It's not production. There's like a common joke that says it works on my laptop, and then it says, but we can't ship your laptop to the customer. So yeah, that's also somewhat of a relic, because we know, as DevOps practitioners, we know how to minimize this gap and compensate for it when it exists. CI, continuous integration. So you do need immediate feedback, but you also need a somewhat deeper and, let's say, a bit more prolonged guardrail. And that's CI. CI is a process, so continuous integration is a process that tests your software with much more depth than whatever is going on your machine. It may also involve cloud resources. It's much closer to production and so forth. It happens automatically. Ideally, it also scales automatically. And it should give you a feedback within the scope of minutes. Maybe not immediately, but definitely a usable scope before you need to switch your context. It also involves creating whatever supporting infrastructure is needed, cloud resources and so forth, which may or may not be feasible when you're working on your own machine. And it also communicates with your source code management, because holding the gate is one thing, but you also need to know to relay that feedback to the developers so that they can respond as quickly as possible. And that helps get bugs squashed. And then we have continuous delivery. Now that's interesting. Now, we've tested the software, but now we need to deploy it. And when deployment was a written document, it was slow and error prone. And then when you had an error, you weren't sure if the error came from not following the deployment instructions, perhaps, or was it a genuine bug. So that's where continuous delivery really shines, because it makes sure your software correctly reaches its designated destinations. It follows approvals and policy at the exact scheme you want it to. Because like we said, deployment may not be a straightforward thing as in, okay, just click install and so forth. And last but not least is automatically reverting it if we know that it's patently bogus. I mean, we can't account for every bug, but if we know that it's patently unhealthy, then we're going to revert it really, really quick, and then the impact on the customers will minimize. And that gives you safety. You know that even if you made some kind of a mistake, and even if it passed the CI, then the damage would hopefully be constrained. There is yet another very important guide rail that helps you focus on working and perfecting your software. And then we have cloud supporting infrastructure. Like I said, back in the days, getting the right infrastructure and coordinating it and waiting for it was an arduous process. And now we have a cloud infrastructure that really helps with various components that can range from VMs to serverless services and many, many more, managed databases and so forth. So that's convenient. That's really helpful for focusing on your own code rather than infrastructure. And in addition, we have the convenience of something called infrastructure as code, which we will explore when it comes to tools, because that can be synchronized with code, managed similarly to code, tested, and so forth. So your infrastructure and code almost become one as needed. It's integrated with CI/CD, and it also gives you the benefit of automatic scaling, because back then you needed to adjust your plans in advance, and that was another slow and error-prone process, and cloud mostly, for the most part, is putting an end to that. And last but not least, monitoring and RCA. So even as we put so much effort into improving our processes, catching bugs, and increasing our safety in what we do, things happen. They will happen. They will always happen. They still do in myriad, like huge quantities. And we need to know they happened. We need to respond automatically if possible, but not always. And then we're going to have to page the DevOps or the site reliability engineer. And then we need to realize what happened, fix it, realize why this happened, but most importantly, we should, if we're practicing DevOps, fix and improve our processes accordingly. If we had a bug that we know that we could have caught in the CI, or even better, during the development process, then yeah, now's the time to implement it and improve our processes. Great. Let's proceed to some of the tools in the toolbox of a DevOps engineer or practitioner that helps us implement those things. Okay, we're going to have a quick look at Minikube and Scaffold for DevX. We're going to have a quick look at GitHub Actions for a CI system, and FluxCD or Argo CD for continuous delivery, and Terraform and Pulumi for infrastructure as code. So, Minikube is a local Kubernetes cluster. Kubernetes is, well, it's sorts of cloud abstraction, if you will, that is very common in deploying software. Now, if you have a local copy of it, then it means that your development environment would be very similar to production. because they would both be Kubernetes. They would both speak the same language, accept the same manifests, and so forth. But just having a local Kubernetes cluster is not enough by, by miles. We need some utilities and tools to interact with it, and that's where a tool called Scaffold comes. It's a utility that drives development tasks, running something in debug, running a selection of microservices, and so forth. And when it deploys those two successfully, it feels just like the real thing, just like your production system, but with extra development-oriented features which are needed for the development process, debugging, logging, and so forth. And that, from personal experience, that actually works really, really nice. And then we have GitHub Actions. GitHub Actions is a very lean CI system that comes integrated with the GitHub, which is a common source code management platform. It's fully managed if needed, which is a real benefit because some of the previous generation CI systems had to be managed by highly competent engineers. It's simple, it's efficient, it's GitOps friendly because the CI manifests are also written as code and managed by the same Git system. And it's a resounding success in the CI world, and it's very considered very efficient and almost a modern day standard for doing continuous integration. But when it comes to delivery, there are some changes because in the recent past, delivery was coupled with the continuous integration system. But now we have an even more upgraded way of handling delivery. Flux CD and Argo CD are continuous delivery systems that are highly coupled with Kubernetes and driven by the GitOps philosophy that everything is code and everything is managed in Git. And then when you commit your code or changes to infrastructure or changes to definitions of Flux, or let's say your Kubernetes manifests or anything, then Flux or Argo would be immediately notified that their reference source of truth have changed and act accordingly and roll it out, and even roll it out smartly with things like canary deployments and blue-green. We're not going to dive into these. There's just so many things in the DevOps world, but let's just say that those are ways to deploy that are prone, that lend themselves to rollbacks if needed, and minimizing the impact on users. So that's very interesting and very efficient, and it's generally becoming the modern day standard for doing rollouts. And last but not least, we have Terraform and Pulumi, which are infrastructure as code tools, which really helps unify your workflows, because infrastructure and code are converging. You have a piece of code, whether it's a dedicated language or even a general programming language, that's designed to describe your infrastructure requirements, and it can even be, if needed, generated automatically from the code and so forth. And then you have the utilities or the environment that can take those manifests or code and apply them. And you have a full ecosystem of infrastructure that can be abstracted this way. Various cloud providers, things outside clouds as well. And it's a real major improvement over having to do this manually or even with scripted tools. It really all converges together. Okay, now we've reached a summary. Let's wrap it up. DevOps is a line of thought that led us to new concepts followed by tools that implemented them, and that ultimately delivered an end-to-end experience for the developer that allowed them to create a system with fewer bugs, a system that fixes bugs, that encourages quality and allows quality to exist with little effort as much as possible. And if you do DevOps right in your team or your organization, your developer experience feels smooth and your developers are empowered to do more and know how to fix their mistakes when these happen. Your CI/CD, your CI/CD protect you from your coding mistakes. Your monitoring gives you follow-up confidence in what you do, and that reduces the impact on customers, both for the benefit of the customers and for your development processes, and you are free to deliver as you please. And some very efficient organizations deliver their software dozens of times a day, which was basically unheard of a decade ago. A decade ago, a delivery would have been something that took months to do. And some still work that way due to constraints, but ultimately the modern way to do it is just to go ahead and deliver. And that's fun. Thank you so much. You have my email, you have my blog, you have my LinkedIn, and feel free to connect.